In our last video, we looked at solving equations and looked at various techniques for clearing fractions, clearing parentheses, and also we looked at linear equations, where we have to get the variable terms on one side through adding and subtracting, and we move the constant terms to the others through adding or subtracting. We're going to continue working with that. With conditional equations, we only had one magic number that made the original statement true. When you upgrade to inequalities, there's a whole lot of answers that can make that happen. And so instead of thinking in terms of one magic number, we have to start thinking in terms of a whole bunch of magic numbers. Let's get to an example. In the top left, we have the statement 2x is less than 18. Well, you can come up with a whole lot of numbers such that when you multiply them by 2, your answer is less than 18. For example, if x is 0, 2 times 0, that's less than 18. If x is 3, 2 times 3 is 6, that's still less than 18. So basically what we want to do is be smart about how we find all numbers that make that statement true, and a good start is to solve for x. So just like you did in the previous video and exercises, when you solve for x, you can divide. Let's divide both sides by 2. That leaves us x less than 9. This statement tells us that any number less than 9 will satisfy the original problem and create a true statement. So less than 9 means we can go all the way up to like 8.999, just not exactly 9. But any number smaller than that is going to be to the left of it on a number line. The farther left you go, the deeper into the negatives. So in interval notation, all answers that give a true statement will be negative infinity to 9, but we use parentheses to say we don't actually get to include the 9, but we can get real close to it. In the upper right example, we have negative 4x greater than 18. When you divide both sides by negative 4, that gives us x, and negative 18 over 4 reduces to negative 9 halves. Notice that the inequality got switched around. If you multiply or divide both sides of a statement, an inequality statement, by a negative, and we had to divide by negative 4, anytime you multiply or divide both sides of an inequality by a negative value, you have to reverse the direction of your inequality symbol. So all answers that give a true statement are going to be numbers that are less than negative 9 halves. Less than negative 9 halves fall left of negative 9 halves on a number line, and because it's strictly less than, we use parentheses at the cutoff number. So all the numbers that create a true statement in the beginning problem are any number from negative infinity up to, excuse me, I made a mistake here. I'll fix that though. Negative 9 halves. I had it right on the graph. I just didn't have it right over here, but I fixed it real quick. Moving to the examples below, we still have linear inequalities. 7x plus 4 less than or equal to 11. Subtract 4 from both sides. That leaves 7x less than or equal to 7. Divide both sides by 7, and that leaves x less than or equal to 1. We did not have to reverse the inequality symbol because we divided by a positive 7. If that had been a negative 7, we would reverse the order. When you get to include the cutoff number, because all the solutions are values of x less than or equal to 1, you use a bracket instead of parentheses at the cutoff number. So all values of x that give a true statement in the original problem will be any value of x smaller than and including 1. The example to your right, 2x plus 10 less than 6x plus 4. Nope, I read that wrong. 2x plus 10 less than 6 plus 4x. With these, we need to pick a side for the x's and then take the constants to the other side. So if we take off 6 from both sides, that leaves 2x plus 4, less than 4x. Now, the constants on the left, we need to move all the variables to the other side. We do that by subtracting 2x's. So that's 4 less than 2x. Divide both sides by positive 2, and that leaves 2 less than x. It's easier to read an inequality if the variable's on the left side of the statement. So notice that the less than is the inequality symbol's pointing to the 2. If you turn all of it around, as long as it still points to the 2, this statement and that statement are identical. Any value of x greater than 2 will fall to the right of it on a number line. Now we don't have the underline, so it's strictly greater than 2. So parentheses at the 2, and when you go right, you go deep into positive values. So our solution set is 2 to infinity. Let's continue solving equations. The top left example, we have 4x minus 9 less than or equal to 9 plus 6x. Variables on both sides, constants on both sides, so we need to smooth those over using adding or subtracting. Let's take off 4x's from both sides, and I believe that was a recommendation given in class, so that leaves us, after subtracting 4x's on both sides, we have negative 9 less than or equal to 9 plus 2x. Subtracting 9, that gives us negative 18 less than or equal to 2x. Finally, dividing both sides by positive 2, that leaves negative 9 less than or equal to x. And like the previous example, turn all of this around and it's easier to read, x greater than or equal to negative 9. Since we get to include negative 9, we're going to put a bracket at that cutoff number. Any value of x greater than that will be to the right of that number on a number line, so our interval will be negative 9 with a bracket to positive infinity. The example in the upper right is called a compound inequality. 1 less than 2x plus 7, which is less than 13. When you run into the compound inequalities, the idea is to isolate x in the middle. So let's subtract 7 everywhere on all three sections, the left, the middle, and the right. 1 minus 7 is negative 6. That leaves us with a 2x in the middle. 13 minus 7 is 6 on the right. To isolate x, we divide by positive 2, so that leaves negative 3, less than x, less than positive 3. With compound inequalities, our answers to the original problem, or any value of x that makes a true statement, will be numbers between but not including negative 3 and positive 3. Just remember, if the inequality is not underlined, use parentheses. The example at the bottom, negative 4 less than 2x minus 3 all over 3 less than positive 4. Let's clear the fraction. Multiply all sections by 3. 3 times negative 4 is negative 12. 3 divided by 3 is 1, so that leaves 2x minus 3 in the middle. 3 times 4 is 12 on the right. Add 3 to all sections. Remember, the goal is to isolate x. Adding 3, that's negative 9, less than 2x, less than 15. And then finally, to isolate x completely, we divide by a positive 2, so negative 9 over 2, less than x, less than 15 over 2. So all of our solution values are between but not including those two numbers.